The point that I was trying to make here, right? And my old students, or they will probably hear me say this a million times, or they're fed up hearing me say this, but when new students, I hear it yet, right? But essentially, you have to understand when you're writing Csec, is a human being going to be marking your paper? Yeah? So that human being, he could reach your paper at 4 o'clock in the evening after it was a hot day and he tired and all kind of thing. And then he had to watch your paper. Right? When he had to watch your paper to mark it, he have to make out exactly what it is that this person trying to do here. So remember, it's not just about you answering a question. You have to make the life of the marker easy. Yeah. So it took me a while to figure out what you did here. You understand? I didn't know. I had to figure out, well, okay, this is a multiply. So that means that this come from this or something like that, you know? And I kind of had to figure out. So okay, you understand what's in here, right? Right. So it's a matter of, and this should go for every question. Just remember, when you're doing your exam, it's a human being marking it, not a machine. So you want to make that person's life easy. You don't want to have this person sitting down trying to wonder, well, what come from what? So how I would answer this question is, I would just remember every question is a story you're trying to tell. And in the story, this is the problem. Right? So I would say, well, okay, 3 and 5 over 9, and you notice how I'm writing it underneath, so everything kind of matching up, and everybody will clearly see what's happening, right? So 3 and 5 over 9 plus 1 over 6 minus 3 over 4, and then I could put multiply by 4 2s are 8 and 1 is 9, 9 over 2, so that is 2 over 9. Yeah. So now the person who's marking could easily see, well, okay, this is the same, this is the same, this is the same, but this is what changed. So this is what the person is doing. And then in the next line, I would have put, well, 3 and 5 over 9 plus, and you notice I keep writing over the same thing over and over, but that's okay, because every line you're going to change something else. 1 and 1 6, and over here I could do the thing and the thing. Just 2 2 1, this is 2 and this is 3, so I'll have minus 1 and 1 6, and then I could have 3 5 over 9 plus 0 to show that this reduced to 0, and then I'll have my final answer, 3 and 5 over 9. So I mean, I wrote it kind of scrappy. Please don't write as scrappy as me. Try to write as neat as possible. But anybody who is marking your paper now, if you write it like this, if you tell a story, then you know it's easy to see, well, okay, they didn't touch this, so they tackled this part here, right? So I go, okay, you 1 mark for that, 1 mark for that, 1 mark for that, 3 marks total, you're good to go, right? But at the end of the day, you know, if it is that I look at this, yes, it is correct, but it takes me a while to figure out, well, which fraction is she working on, you know? And exactly what part of the question is she working on? Yeah, is she working on this part? Is she, because you understand what I'm saying, right? Right. So Katie gets a 20% pay rise. Her new wage is $264. I'll just see pounds and I'll call it dollars, right? What was her wage before her pay rise? Anybody want to give me their thoughts on this? How do we do this? Quick. The quicker you say something is the quicker we get to go home, right? Right, because her wage before, thank you very much, that was Soraya, right? What she's saying is Katie gets a 20% pay rise, right? So her new wage is this. This is her new wage. So this is with the increase of 20%. So that means that now she has a wage of 120%. That is the 100% she had before, plus the 20% increase, and that gives her $264. So $264 represents 120%. And I have a designated calculator lady in the class, but she not very quick on the draw, right? So I gonna have to do it myself. So 1% will be 264 all over 120, and of course 100% will be 264 all over 120 by 100. Multiply by 100 is equal to, right, so her pay before was $220, right? And that is the thing, if you tell a good story, right? So you can see here, even though this is quite scrappy, it tells the story. It makes the statement that, hey, 120% is that. And then it carries a logical story as to how we get to the answer. So a person who marking it would see 169 and would say, oh, she do a problem with that. So let me just say I had to get 1 mark for this this one, and 1 mark for this one, and then 1 mark for the final answer, right? You do 169, you wouldn't lose all your marks. You'll probably just lose this mark here, right? But this is something called error carried forward. So yes, you made an error over here, but you didn't make an error here or here. No, you did these things correctly. So you would get the marks for that. So you would have probably get 2 out of your 3 marks. It depends on, maybe you would have get all 3 marks depending on who is marking your paper. And that is why I always say you have to think about that person. The person is marking your paper. You want to make that person happy, right? So one of my new students should tackle this one, right? So Ivan whoever is the 2012 Olympic high jump gold medalist, and he jumps 2.4 meters, right? This is 4% lower than his best height. So what is his best height? Right, interesting. That is interesting. That is a very interesting thing. So what she is saying here is that he jumps 2.4 meters, and this is 4% less than what he does normally jump. So what he does normally jump, we'll call that 100%. And it's all about identifying what is the total, what is 100%. So 100% is what he normally jumps. But here he jumps 4% less, so minus 4%. So here he only really jumping 96% of what he could jump. So 96% is equal to 2.4, right? So you said you multiplied it, but let's see if it works, right? 1% is the 2.4 divided by the 96, right? 2.4 divided by 96 is equal to that. Zoo, look, 0.025. So obviously 100% would be 2.5 meters. A pack of ping pong is 24% bigger, right? Now it contains 31 biscuits. How many biscuits did it have before? Sarah, let me hear what you think about this. And I'm not putting you on the spot. If you don't know, just say you don't know. It's all good. Yeah, but that's okay. You think about it now. Think about it now, because it's not as different as any of the others, right? It's 24% bigger. Now it have 31. So the 31 it have now, the 31 ping pong it have, or biscuits or whatever, the 31 is 24% bigger than what it had before. So what do you think that means? Alright, that is no scene, but let me talk it through, right? If it's 24% bigger, right, then like the amount that it had before, if we call that 100%, right? The amount that it had before, 100%. And now it have it 24% bigger. So I'll add the 24, you get what I'm saying? Right, so now it's 124%. We could see that that is 124%. And 124% is 31 biscuits. You understand what I'm saying there, right? Alright, is no scene. I'm not just explaining it to you, I'm trying to get it to everybody, right? So at the end of the day, this 100 is what we want to find, right? So you always kind of had to decide what the total is. How many did it have before? Well, I could say, well, 100% is how many it had before, and they increased it by 24%. So now it's 124%, and that is 31 biscuits. So therefore 1% is 31 divided by 124, and now I could find the 100%. And you could bet that this is gonna end up being less than 31, right? So 31 divided by 124. Right, so actually, so this gives us 0.25. So 100% now will be 25. Right? 0.25 by 100 goes like that and like that, and you get 25. So Sarah, you understand how I get 25? Everything cool with that? All right, good job. At the end of the day, you could see here that 124% being 31 biscuits is more than the 100%, which is 25 biscuits. That's a lot more biscuits actually. That's plenty more biscuits, you know? Like I wish that local people, like snack people, could actually, instead of putting A in the pack, because that is what it is give you more of. It is give you more A in the pack, right? So Jordan, see if you could tackle this one now. Del Boy, I don't know what is Del Boy, sells his goods in our market for $66.70, making a profit of 15%. How much did he pay for the goods when he bought them? That's fine. As I say, it's cool. I don't really care about the numbers. I care about the reasoning. So where's the reasoning? Right? So wait, slow down. So remember, we have other students here who might not know what you're talking about. So let me take it slow, right? So 100% plus 15%. Why 100 plus 15? Why? Because he made a profit. Yeah? So it's not an increase in goods, but he made a profit. So whatever the 100% is what he spent, and then he make 15% on top of that. Right? So what he made here was, what you're saying is he made 115%. Right? And what is 115%? Right. I ain't reach all that yet. I ain't reach all that yet. No, you're speeding. I just ask you, what is 115%? That is the $66.70, right? Yeah. You see how slow I just think, eh? And that is the difference between me and Olia, and why Olia will make so much mistakes, because Olia just want to speed. You see how slow I go in, right? That's a slow kind of guy, right? So at the end of the day, 115%. Because you see, he sold his goods in the market for that amount, making a 15% profit. So for this amount, he made the 15% profit. So that is 115%. That is the 15% on top of the cost price, right? The profit and the cost price. So 115. So now we could say 1% is 66.70 over 115. 66.70 divided by 115. I miss my calculator, lady boy. I miss when she was all helpful and thing, right? 100% now is 0.58 multiplied by 100, which is $58. So this guy bought something for $58. So $58 here, and then he sold it back for 58 plus 15%, which, well, we could find, whatever, to get the 66. So what's the 15%? That'll be 66.70 minus 58. And the 15% is, so he add on $8.07 there, right? So the 58%, the $8.07, and that is it. Any questions on this stuff so far? Since being on a strictly come dancing vanilla, has lost 20% of her body. Since being on strictly come dancing, Vanessa Feltz, has lost 20% of her body weight. She now weighs, well, alright, so whatever she was on, let's just say, since being on a diet, alright? Oh, yes, I don't know. So let's just say, since being on a diet. What's that?
At the end of the sentence, how much you should read for the show.
Oh, I see. So it's a show. Okay, but why they had to do all that? It's a percentage question. You don't have to, why? Right? So this person lost 20% of her body weight. Now she weighs 90 kilograms. So she weighs 90 kilograms now, but that's after she lost 20% of her body weight. So what does that mean, Aris? Excellent, right? Right, so 80%, right? So she lost 20%. So her body weight was 100%, but she lost 20%. So now she's at 80% of her body weight, which is 90. And now we could just do the normal thing. 1% is 9 over 8, actually, because the zeros will cancel, right? And then 100% is 9 divided by 8 multiplied by 100 gives us 112.5 kilograms. So a new car drops in value by 30% in a year. And this is a CSEC question that they kind of like to ask in CSEC, right? After a year, its worth is this. Find the price of the car when it was new. Okay, you want to give this a try? Right. And that is great. That is great, right? If you wasn't too sure on thing, let me see how we could think about it so that we could be sure, right? So a car, let me call it a car, drops in value 30% in a year. So drops is subtract, right? So 30% in a year. So at the beginning of the year, the car is 100%, but then it drops in value by 30%. So at the end of the year, it would be 70%, right? So okay, you think that makes sense? Right. So now after a year, right? So after a year means that it is now at 70%, right? So at 70% after a year, it's worth this. So 8,400, right? Find the price of the car when it was new. So when it was new, it was 100%. So same thing. You notice that all of these questions basically boiling down to the same thing, right? It's just a matter of what you identify as being 100%. That is what it's all about. 8,400 divided by 70. I was having a calculator malfunction there. So it would have been 12,000. During the mid-season sale, a shopkeeper sold 60% of his Kindles, right? So then he found that he was only left with 50 Kindles. So he sold 60% of the Kindles and he had 50 Kindles left. How many did he have in stock to begin with? That's fine, try it now. And just think about it, and you could like just talk it through and talk out loud and say as many wrong things as you want. I don't care, right? But let's try it. Why? Wait, before you start to jump into 100 and plus 60, why did you do 100 plus 60? Why? Right. So before, because I'll tell you, 100 plus 60 is not the correct answer, right? But before, because you just jumped at that because you saw that we were doing a lot of that in the other questions. But just think about it, right? Think about it. So look at the question, right? He sold 60% of his Kindles. So if he sold 60% of the Kindles, what percentage does he have left? Right, so you see, right? He found that he was left with 50 Kindles. So 50 Kindles is actually 40%, eh? Right, so he had 100 and he sold 60%. So that means he only have 40% left, yeah? And he have 50 Kindles left, so that means that 40% equals 50 Kindles. So therefore 1% is 50 over 40, and 100% will be, let me do that, 50 over 40 mod. Very good. So he had 125 Kindles. Jacob answered 80% of the questions in a test correctly. He answered 32 questions correctly. Work out the total number of questions in the test. Anybody, I'll open this up to anybody. So what you're saying is 100 minus 80 to find out how many questions he got wrong, right? Yeah. But I mean, that's correct. That's totally correct, right? Because if he get 80% correct, then obviously he get 20% wrong. But my question to you, Caitlin, is that what the question is asking you for? Is the question asking you anything to do with how much he get wrong? That's right. So what is the question asking you for? So what percentage is the total number of questions? Remember, he get 80% correct and 20% wrong, right? So what percentage is the total? Yes! And I'll tell you something, in this maths class, I just only ask easy questions. Every question I'm going to ask you is going to be an easy question. The only thing is you have to figure out how is it easy. It might seem hard, but just remember it's easy, right? So we actually want to find the 100. What do we know, right? And what percentage is 32?
80.
Right, so we know that the 80% represents 32 questions. So now we could just work it normal. 32 over 100, which is, no, 32 over 80, sorry. So therefore 100% will be 40 questions. So how many did he get wrong, Caitlin? Yeah, but you're overthinking, Caitlin. You're thinking too much. And that's my problem with all earlier thinking too much. So what we're going to talk about today is we are going to talk about the topic of ratios. And yes, you will find this document in your Google Classroom. I will show you where it is, right? And I chose this image because ratios really do represent everything. Everything, right? So first of all, let's write this little note, right? We have fractions here now, right? And you know we had all of the different types of fractions, and we saw 5 different types of fractions, right? You notice I didn't count the ratio as one of them, right? We had the proper, we had the improper, we had the mixed, we had percentages, and we had decimals. And you notice I didn't count ratios as one of them. That's because all of them are ratios. A fraction is a ratio. Yeah. So when we're talking about fractions now, you know, you have like a fraction like 1 over 2, and it have many ways that we could think about this thing, right? First of all, in terms of the parts, this is your numerator. This here is your denominator. And you know your numerator, we could also think about it like it dividing. So 1 is being divided by 2. So the top one here, the thing that is being divided is the dividend. And the thing that is doing the dividing is the divisor. But here's the question, where's this little line here? What do you call this? Anybody? For 10 points. Ah, you're close. You hear me say it in a video. Alright, yes, you're close. It is the vinculum. And I surely remember learning this in primary school. And it was probably in the back of your mind somewhere. Right? The vinculum. Right? So it has many ways that we could think about this. But we can also think about this as a ratio. And we're going to see that we're going to start to write a fraction like this now. Sorry, not 3, 2. Right? Now, the difference between this and this, there are differences. For example, right? With a half, 1 being divided by 2, you could think of the total as being 2. So, you know, in a pizza, you have 2 slices in a pizza, right? And Caitlin come and thief one of the slices, right? So she just come and eat it and gone. right? Like a Tiffany knife. And you are only left with one out of the two slices, yeah? But did you know that if you look at it in terms of a ratio, this actually could represent two different fractions, right? A ratio is kind of like saying, well, okay, for every one slice of pizza that I have, Caitlin will have two slices of pizza. So the ratio is 1 to 2. And it could also be written like this, 1 to 2. So it looks like a fraction, yeah. But it's actually not one fraction, you know, it's actually two fractions. Because if you look at it, right, this here is two different fractions. Because for every slice of pizza that I have, Caitlin have two slices. So how many slices are there in all? There are actually 3 slices in all. And out of all of the slices, I have 1 and Caitlin have 2 out of the 3 slices, right? So you could see here that this ratio actually represents 2 different fractions. Right? And this is one of those things that has confused us, right? So I hope that you guys wrote this, but we are going to have some more writing to do. So how about let's give this a write down, and I want to hear 3 or I want to hear 5 done it's. Right? So write this down, let me hear 5 done it's, and then we'll talk about it. So a ratio is a relationship between 2 different things, right? So I have 1 slice of pizza, and it doesn't even have to be pizza. It could be for every 1 slice of pizza I have, Soraya have 2 bag of ping pong or whatever, you know. So in that way a relationship is formed, right? So for every for every 1 slice of pizza that I have, Soraya could have 2 bag of ping pong, right? I guess I'm feeling for ping pong these days. So that means that if I have another slice of pizza, then Soraya will have another 2 bag of ping pong. So you can see here that I have 2 slices of pizza to 4. So we could call this a ratio 2 to 4. But if we treat it like a fraction, we could reduce. And this is the only time that we want to treat a ratio like a fraction, in order to reduce it. So I could see that 2 could go into 4, so it's actually a ratio of 1 to 2. So a ratio of 2 to 4 is like a ratio of 1 to 2. Now, you could see that it kind of works like simplifying the fraction. Simplifying the fraction allows you to find the ratio in its simplest form, right? But remember, a ratio actually stands for 2 different fractions. So let's talk more about it. So it's a relationship. I just formed a relationship between my pizza and Soraya's packs of ping pong, right? So it is a relationship that is used to compare 2 or more quantities. The ratio of n things to m things is given by n to m. This is how we write it, right? So the ratio of n to m can also be expressed as a fraction. And as I said, expressing it as a fraction is only useful when you want to simplify the ratio, right? So over here now, and I'd like you guys to give this a write down as well, right? We have some blocks here. And how many blocks do we have in all? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks in all. And you can see that 1, 2, 3, 4 blocks are shaded. So in terms of, you know, shaded blocks, right? We have many different ratios here, right? Let me start with the first one, right? We have the ratio of the shaded blocks to the unshaded blocks. So we have 4 shaded blocks and 6 unshaded blocks, right? So 4 to 6. That is the ratio. And you can see that 4 to 6 could be described as a fraction where I could simplify it as 2 over 3. And so the ratio is actually a 2 to 3 ratio, right? However, remember that this here represents, because 4 shaded and 6 unshaded means that I have a total of 10 blocks. Having a total of 10 blocks means that I actually have 4 out of 10 blocks, and there are actually 4 out of 10 blocks shaded, and then 6 out of 10 unshaded blocks, right? So it have many ways we could think about this ratios thing. When we have the shaded region to the total area and the unshaded region to the total area, that is what I was just talking about. Because we see here that just from this alone, we could see that it have 4 and 6 is 10 blocks. So it have 4 out of 10 shaded blocks. So look that here. Shaded to the total area, 4 in 10, which is a ratio of 2 to 5, right? Because I just reduced that, 2 to 5. And then we have an unshaded region, which is 6 unshaded blocks out of the 10. So 6 out of 10 unshaded blocks, right? Which is a ratio of 3 to 5. So yes, we could use the fraction form in order to reduce the ratio to its simplest form. So let me take a look at this, right? So in a class of 50 students, so 50 is the total, right? 28 are girls, right? So I'm not even going to read the rest of the question, right? So 50 students minus the amount of girls, 28. So that means that 50 minus 28 is 22. So that means that I have 22 boys and 28 girls, right? Determine the ratio for the number of girls to total students. So I see I have 28 girls with a total students of 50. So A will be 28 to 50. That is the ratio of girls to total students. And of course, I need to simplify this. So 28 simplified to 50, right? That actually reduces to 14 over 25. So this ratio in its simplest form is actually 14 girls for every 25 total students. Girls to total students, right? B, boys to girls. Well, I could see here that for every 22 boys, I have 28 girls. So boys to girls, for every 22 boys, I have. And you notice something, eh? They put boys first in the question. So I am writing boys first. I don't want you to come and put 28 to 22. That is not the same, right? So 22 boys for every 28 girls. And that could be reduced, 22 over 28 reduces to a ratio of 11 to 14, right? And as I say, all I did there was I put 22 over 28 and I reduced it. So 11 2s are 22 and 14 2s are 28, right? And C, I have the ratio of boys to total students. Well, I know I have 22 boys to a ratio of 50, 22 to 50 total students. So that is 22 over 50. So that reduces to 11 to 25 is the simplest ratio. So you always want to reduce to your simplest ratio, right? So let me hear 5 done it when you finish write this, and then you guys are going to do some questions. And let's see how you guys are going to do with these. I'll just leave you guys with these 3 questions. 1 to 3 minutes. Let me call it 4 minutes. 1 to 5 equals 4 to 5 for the first one. All right. She mixes 50 ml of orange juice with 200 ml of water. So the ratio of orange juice to water, so for every 50 ml of orange juice is 200 ml of water. So that is that, and then we just had to reduce that so we could think about it like a fraction, right? So 5 fours are 20. So it's actually a ratio of 1 to 4. You get what I'm saying there, Soraya? So how come you got two different ratios? What did you do?
I accidentally added 4.
Oh, I understand. Yes, I see, right? So for every one part of, so for every 4 parts of water, you're putting 1 part orange juice, right? So you could tell here, like if you have a jug, you could tell here that the jug is going to have 5 parts of liquid, yeah? And 1 out of the 5 parts of liquid is going to be orange juice, and 4 out of the 5 parts of liquid is going to be water. So is this what you did there, Soraya? Right, this is not wrong, it's just not what they asked you for, right? They just asked you for the ratio of orange juice to water. And what this is this is the ratio of orange juice to total liquid, yeah? And this is the ratio of water to total liquid. So you can see here that there's mostly water, right? So and you, Soraya, are definitely one of my classic students who just like to overthink everything, yeah? But not to single you out or anything, but you definitely do overthink things. I can't say it wrong though. It's not wrong what you did there, right? A football match, there are 3,000 men and 1,800 women, right? Write down the ratio of male fans to female fans. Well, I have 3,000 male fans to every 1,800 female fans. So therefore, that is 3,000 over 1,800. Zip zip. So I have 6 trees are 18. 6 trees are 18. And 10 trees are 30. And then I could go 2 trees are 6, 5 twos are 10. So it's actually in its simplest form a ratio of 5 to 3. 1, 2, 3. So we're dealing with 3 quantities here. Share sweets in a ratio of their ages, right? So 12 years old will get 12 sweets. 9 years old will get 9 sweets. 3 years old will get 3 sweets, right? Write down the ratio of their ages in the simplest form. So the ratio of Aidan to Bill to Kara. Aidan is 12 to Bill, which is 9, to Kara, which is 3. Look at that. I have 3 quantities in a ratio here, right? And I could think about it like a fraction like this, 12 over 9 over 3, you know? And you could kind of reduce it the same way, right? You can reduce it the same way. Well, you know, 1 tree is 3, 3 trees are 9, 4 trees are 12. So the answer here is a ratio 4 to 3 to 1. Yeah, so this is an interesting one because we can see here that ratios don't only have to have 2 quantities, they can have more than 2 quantities. But I doubt you will ever get a question that has more than 3 quantities though, right? So we have a couple of ones over here, right? In the nursery there are 5 adults and 14 children. The ratio of adults to children, write the ratio of adults to children in the form 1 to what? In the form 1 to something. That is okay, that is okay. Just pretend like, don't be like you're on the spot trying to answer the question one time. No. Take it. What's the first step? The first thing that you would do. They want the ratio of adults to children. So what's the first thing you would do? Very good. And that is how we like to do it here. We like to take it step by step. So 5 adults to 14 kids. And now they want us to reduce it so it'll be 1 to something. And so 5 over 14. How can 5 go into 14? How much could 5 go into 14? If I have 1 here. 5 2s are 10, and then I'll have 4 remaining, and 4 over 5. So this is actually a ratio of 1 to 2 and 4 over 5. See what's going on here? So yes, a ratio does represent a relation, but that relation could have fractions in it as well, right? So I hope you guys write down this question and this answer too, and I hope that you all did this number 3 because they are quite different, right? But you can see that the thinking for it is pretty okay. Ellie is making a cake, and this is a really good question in terms of how we use ratios every day, because I'm sure a lot of you guys cook and bake and all sorts of kitchen stuff, right? I just cook all kind of cool things. I could cook all kind of madness, like dal and rice. I could stew, I could curry, pilau, all that kind of thing. But I actually can't bake. I never really tried baking anything. You know, baking to me just, I don't know. I like to watch things frying. I don't like to put it in the oven and hope it come out good. You know, I don't like that. You know? So Ellie is making a cake. The instructions say the ratio of sugar to flour to be 1 to 3. She uses 200 grams of sugar and 250 and 650 grams of flour. Did she use the correct ratio? Anybody? Did she use the correct ratio? Now, that is true, but that is not the first step. That is like the second or third step. The first step I would do is say, well, all right, she used the ratio 250 to 650. And?
Yes.
So when I say first step, I really mean let's get elementary with this thing. Like we take real baby steps here, right? So therefore, now I would do what you saying, right? So that's really 25 over 65, right? That's right. So 25 over 65, well, 5 5s are there. So this is 13. So this is a ratio of 5 to 13, right? And if we want, well, 5 to 13 is in its simplest form, but we could go down to 1. 5 is 5. 5 2s are 10, and then we're going to have 3/5 remaining. So you could see that she didn't quite get the correct ratio. Yeah, she didn't quite get the correct ratio at all, right? So Jordan, you understand what I did there? That's cool with you? Like an improper? Yeah, you could have an improper, no problem. But I just put it as a mixed number because it makes it easier to understand, right? So you could tell, because 5 2s are 10, 11 2 are 13. If I had left it as 13 over 5, right? You could see that, well, the ratio we wanted was 1 to 3. I'm not really sure how close 13 over 5 is, you know, to 3, yeah? I'm not sure how close but if I put it as this, 2 and 3 over 5, well, I could see that, hey, she almost have 3, eh? Yeah? So the mixed number actually makes it easy to understand. Remember, you don't want to just give an answer, because when you just give an answer, you can't go and check it back. You want to be, whenever you give an answer, you want to understand the answer that you're giving, and you want to understand why you give the answer. And once you understand, that is the only way that you can check back your work, because you can't check back your work when you don't really know what you're doing, right? So at the end of the day, but absolutely the answer to your question is yes, you can leave it as an improper fraction, no problem. But this is always better manners, you don't find so? It's clearer, right? So, right. So we have some more ratios questions here that are more of the same, and I would invite you guys to try to do some of these questions, right? And check this one, right? Check this one. Find the width to height ratio of each rectangle in its simplest form. Right? Well, then find the perimeter and the area, but you don't have to do this part of the question, because perimeter and area, well, that's easy to do, but you know, this is not a geometry topic. So that part of the question you know how to do. We go tackle perimeter and area when we do geometry, right? But I want the ratio of the width to the height. The width is 18 and the height is 33. And I could see, and you know how at the end of the day, this here is the simplest form, this one. I could reduce any ratio to 1 to n or 1 to something. I could reduce it straight down. But generally, I do not like fractions and decimals in my ratio. I don't. Yeah. Sometimes they're hard to avoid. Like in this question, they literally asked you 1 to n. And you could see 14 don't go into 5, don't go into 14 at all. So you will have some sort of a remainder. So in this question, you had no choice but to have the fraction inside of there. But generally, I do not like fractions in my ratio. So generally, this is the simplest form of the ratio. Yeah, basically reducing the simplest form of the fraction. Because I don't want to have a fraction 1 over 2 and 3 over 5. That is just craziness. But sometimes it might be necessary, right? So in this case, 18 to 33. Can 18 go into 33? Yeah, it can actually. This is a ratio of 6 to 11, right? So this is just an example of how to do this question when it comes to the width, 18, and the height, 33, right? And of course, I'm using height as the vertical one, right? So you guys could tackle all of these questions here. They're quite interesting, right? This is just, they actually gave you the ratios here and you just have to reduce it in its simplest form. And then you have these little visual ratios here that are quite easy to figure out, right? But this brings us to our next topic, because as you can see, ratios just compare things. And if we look here, we could compare all kind of things. You could compare one side of the yard to the next side of the yard, you know, or one side of the house to the next side of the house, and you could express that as a ratio, right? So one side of your room to the next side of your room, you could express that as a ratio. So we'll have a little more writing, don't worry, I promise we're almost done, right? Ratio and proportion, similar shapes, right? So shapes can be related by a ratio as well. And you should write this and draw this, right? If the sides, and notice the topic here is similar shapes, right? So if the sides of one shape is a ratio of the sides of another, we could find something called a scale factor, right? So take for example this, right? I have this triangle here with sides all 2. And I have this triangle here with sides, all of them is 6. So if I was to take this side and this side, just those sides, I could see that that is a ratio of 2 to 6. Right, for every 2 centimeters here, I have 6 centimeters here. And I could reduce that to a ratio of 1 to 3. Now, you'll want to reduce this to a ratio of 1 because you want to find the scale factor is 3. And what does the scale factor mean? Well, the scale factor is the number that you have to multiply. If I take this triangle and I multiply it by 3, I will get this triangle. So the scale factor tells me that this triangle is 3 times bigger than this triangle. And how did I get the scale factor? Well, I used a ratio of the sides. So I could see that the ratio of the sides is 2 to 6. So therefore, for every 1 centimeter, I have 3 centimeters. And therefore, the scale factor is, well, for every 1 centimeter, you multiply by 3. So if I have 2 centimeters here, I'll multiply it by 3, I'll get 6 centimeters. here, right? So this is when it comes to the ratios of the sides and introduction. Scale factor is something that we will see again in geometry. We will see it again in not only in geometry but in vectors and matrices as well. We will see scale factors, right? So write this down and let me know when you're done. Now if we look at it here, we don't have a triangle this time. We have something a bit different. You can see here that the sides are different. This side is different from this side, right? So first of all, what I'll have to do is I'll have to compare the corresponding sides. So this side here, this tree here, I will compare that to this 12. Yeah. So I could see that the ratio of those particular sides are 3 to 12, which is a ratio of 1 to 4. Okay, well that is good. These sides are in a ratio of 1 to 4. The problem is that all of the sides are different, right? So I have to check the other sides too. So now I could check this side here in relation to this side. And I could see that that is a ratio of 2 to 8, which also works out to 1 to 4. So okay, alright, that is great. So I could see here that when I did this first side here, I got 1 to 4. And now when I did this second side here, I got 1 to 4. So it's safe now for me to say, well, okay, then that means that the ratio of the whole shape is 1 to 4, and so the scale factor will be 4. Meaning that if I take this smaller shape and I multiply 3 times 4, I'll get 12. If I multiply 2 times 4, I will get 8. So therefore this shape here is 4 times bigger than this one. This shape multiplied by 4 will give you this shape. Nice. So write it down, let me know when you're done. We do have some questions here, and you could try these questions if you want, but they are quite easy, right? For example, enlarge the shapes using a scale factor of 1 to 2, right? So that means that the scale factor of 1 to 2 means that for every 1 centimeter on this shape, I will have 2 centimeters on this shape. Yeah? So for example, if this shape has 3 centimeters on the side, the scale factor is 1 to 2. So therefore I'll multiply by 2, and 3 2s are 6. So I will have 1, 2, 3, 4, 5, 6 centimeters on this side here. We can see I have 2 centimeters on this side, so 2 times the scale factor means that I'll have 4 centimeters on this side here. And this is what the enlarged shape would look like, right? Again, if I wanted to do 1 to 2 over here, well, I could see that this is 1, right? So if this is 1 in the enlargement, that'll be 2, right? I could see here that this cutting across one square, it cutting across. So in the enlargement, it would cut across 2 squares, right? This would come down 2 squares. This will go across 2 squares, and so we go in like that, like that, like that. Oops. 2 squares here, 2 squares here, 2 squares here, 2 squares here, 2 squares here. Yeah, looking real abzucky. I'm supposed to use a ruler and such, but it's really just a sketch, you know, to get you guys kind of, you know, understanding. So you can see here that with ratios we can actually do all sorts of things with geometry as well. And in this case we actually have to reduce the size of the shape, right? So we will have a larger shape here and we want to reduce it. So this is a 3 to 1. So for every 3 centimeters we want to reduce by 1, right? So what is this here? 3, 1, 2, 3, that's 6, 1, 2, 3, that's 9 centimeters here, right? So that means that if this is 9 centimeters, right? 9 centimeters, that means that on this side I will have 3 centimeters. So it's a scale factor of by 3, I guess. So on this side I'll have 3 centimeters. On this side, well, this is 3, so here gonna be 1, because 1 to 3, right? Over here I have 6, so that gonna be 2. Over here I have 3, 6, so that'll be another 2, and then 1, and then like that, and that is what the small shape would look like.